Acisa has been designing and manufacturing its software and hardware solutions for cities, roads, and tunnels, aimed at optimizing traffic systems for more than 50 years. And in the last decade, all city solutions have been aimed at optimizing traffic systems. It's one of the smart mobility pioneers aspiring to leverage open technologies in the cloud and edge computing fields. This use case will explore the use of the V2X service over COGNIT for emergency vehicles and public transportation in a smart city context to avoid impact response times for emergency services or cause delays to public transportation. When a bus from the public transport system of the city is approaching, the M-Hub will make a decision based on various parameters. The controller chooses either it will try to extend the time of green to allow passage within the same signal phase as illustrated in the left figure, or it will instead try to minimize the time to green as illustrated in the right figure. Acisa is currently equipping in Granada intersections with its new M-Hub and V2X systems to provide public bus prioritization for the bus line, consisting of 18 buses, 38 M-Hubs, and 114 intersections, and has been selected to be used as testbed for the COGNIT project. Each bus is equipped with a V2X onboard unit that communicates with the roadside units installed at each intersection. The RSUs are connected to the M-Hub, which provides enhanced edge computing capabilities and interfaces with COGNIT and Saturno cloud platforms. These are simple images deployed on field, that is, onboard unit, road street unit, RSU, and traffic light controllers, TLC. In this figure, we have 3 sample junction maps, and it is showing data from the detectors for each junction, which are being collected in Saturno. Every intersection is configured in Saturno following the V2X standard. The basic configuration includes all incoming and outgoing lanes and the allowed movements between them. Upon receiving a priority request from an authorized vehicle, the M-Hub may initiate a function call to the COGNIT function as a service, including additional contextual information to execute on-demand traffic simulation using Sumo. This is some heavyweight functionality that wouldn't make sense to deploy on the M-Hub devices, and will be leveraged using the remote function as a service to calculate some complex simulations and obtain KPIs to make decisions about priorities. Bus delay data for each bus are updated in Saturno every 5 minutes. From this data, we derive a synthetic value of the traffic congestion status, which is sent periodically to the COGNIT data as a service system. This traffic condition is an important input for the simulation, and the function executed in COGNIT injects it into the Sumo execution. This is a graphical representation of one of the executions of the simulation on the model for the junction 1001 Sumo model updated with intensity measured by inductor loops. M-Hub plan in public transport. The function as a service will take into account both the traffic current situation and simulations. If there are no simulations applicable, the algorithm will produce them by calling to the simulator. Each M-Hub will ask the COGNIT edge, function as a service, before deciding priority strategy. In this view, we can see real-time traces. Top left, the Mobility Hub Edge process receives a priority request and sends a request to the device client. Down left, the device client is sending the request to the serverless runtime. Top right, the serverless runtime receives the requests and calls Sumo. Down right, we see the result of the simulation by Sumo. The serverless runtime function as a service calculates that the delay is over the threshold and grants the priority. The device client sends the priority grant back to the M-Hub edge. In this video, we see the full execution of one bus detection and the priority request processing. In following slides, we will analyze in detail the information shown. A request for priority is received in M-Hub as a V2X message, and the M-Hub initiates a remote function as a service request. In this image, we see a request in which the priority is granted. In this sample trace, there is no pre-calculated priority results for the current condition. Then the mHub is making a request using the device client. The COGNIT serverless runtime requests a simulation execution for junction 1001 and congestion status high. The Sumo simulation gets executed. Sumo performs the simulation. The device client compares the value of the simulation returned by the FAS with the threshold which grants the priority. In this case, as it is bigger, the bus gets priority. Hub Edge receives a true response to grant priority. In this video, we have a new request in which the priority request is rejected. The bus V2X event is detected and a remote priority call is requested in the mHub. The COGNIT device client requests the function as a service execution. The serverless runtime calls the Sumo simulation for junction 1001 and low level of congestion. Sumo performs the simulation. A result for time loss is obtained in the serverless runtime and is returned to the device client. The device client compares the result with the threshold and make a decision of rejection. The mHub receives a rejection for the priority request. The following features of the COGNIT framework are of particular relevance to his use case. Enable seamless deployment of function as a service and data's on premises and specific nodes. A typical medium city may have 200 intersections on average. We may consider a maximum rate of 10 priority requests per hour per intersection. That is an upper limit of requests per hour in an average medium city, or 20 concurrent requests by the different mHub clients. COGNIT will help ensure serverless runtimes will be available to run Sumo simulations 24/7. Next, we will show some examples of the execution of the function as a service in the instances created in the Edge cluster in Barcelona. This provides a central point of view about how the instances of the serverless runtime are created and how they are processing the requests of the functions as a service. This figure shows different instances that have been created automatically by the autoscaler feature. According to the demand, the instances are scaled up and down to find a balance between computing resources and capacity. The front-end instance is in charge of receiving requests and forwarding them to the service instances. This figure shows samples of logs from different service instances. The requests are spread by the front end and are processed in different service instances to balance the workload. These logs are an extract of relevant events with regard to the COGNIT device client. In this detail view, we show two different requests. For each one, we see in the red square the parameters of the request, starting with city and junction code. In the blue square, you can see the result calculated by the simulation.